Good.
All right. Our next speaker is Ling Lin from CERN, and he will talk about 8D and 9D string vacua via junctions. Please go ahead, Ling.
Okay. Well, thanks again for Fabian, Pablo, and Vera for giving me the chance to speak here and also keep the seminar series going. So today I will talk about some work that most of it appeared in a paper from last month, but also there are some details from an earlier paper of last year with Miriam, Marcus, and Hao. And the motivation for this fits very nicely into the broader swampland program, but maybe more from a perspective. So one goal of this broader program is, of course, to understand whether or not string theory is a unique theory of quantum gravity. And I think it's needless to say that the more stringent your theories are, the better chance you have of proving this. And so the natural place to start is with supersymmetric string vacua in high dimensions, where already by the power of supersymmetry, a lot of constraints come for free. But nevertheless, it's, as you all know, it's non-trivial to really prove what people call string universality or the string lamppost principle, namely showing that really all supergravity theories that are consistent quantum gravity theories come from string theory. And so within this program, one aspect of these supergravity theories that I'm quite interested in is how you exactly characterize and constrain the gauge group topology. And this is some data usually not accessible from a low energy perspective, but really requires some UV input. And at least the starting point for this broader program would be to sort of really categorize and have a good computational tool to compute these things, at least in the consistent supergravity theories we know arise from string theory. And finally, these kind of theories also provide a good testing ground for broader swampland conjectures, some of which I've already heard from Juta's talk. And I will try to follow up on that towards the end of the talk. So for this talk, I will start with a review and some detailed explanation of maybe some older facts about string junctions that provide a dual description for F-theory compactifications on K3. And then I will try to generalize these properties to theories that include an O7+ brane, or which in the geometric phase are usually called frozen singularities. And finally, I will talk about how you can uplift these theories, including O7+ branes, via some suitable infinite distance deformations that correspond to a 9D emergent description. Okay, so I think by now F-theory sort of has become a very standard way of talking about non-perturbative string vacua, but it's sometimes good to recall that there used to be a time where we would introduce F-theory as some dual description of type 2B with PQ7 branes. And this is sort of going back to the roots of this type of description, where the junctions come into play. And at least for this type of F-theory, vanilla F-theory constructions that realize gauge theories of rank 20, two of which are graviphotons, so they are always abelian, and rank 18 can be the maximal rank of a non-abelian gauge symmetry. And in these theories, the 7 branes are usually you can think of string junctions as just strings stretching between 7 branes, and in the dual F-theory description, they correspond to M2 branes wrapping certain 2 cycles that you obtain by fibering some vanishing cycle in the fiber from one singularity to another singularity. And you can have junctions that stretch between 7 branes, but also in a non-compact setting, at least, some junctions that go off to infinity. And within this setting, it's within this dual description, it's very natural to have a pairing defined on the set of all junctions, and that induces a lattice structure on the junctions. But it's important to emphasize that in the original way this was constructed, the junction pairing sort of was written down independently of any geometric incarnation, and this is sort of also relevant for later when we go to the frozen phase where we don't really have a good understanding of the geometry. But nevertheless, in this standard way, it's very easy to verify that this junction pairing is identical to the intersection pairing in geometry, and this lattice you construct contains a root lattice of some gauge algebra G that is realized field theoretically if you imagine colliding these 7 branes to a point. And the root or the W bosons of this gauge theory come from string junctions that stretch just, as I said, between individual 7 branes that constitute the stack. And you can also have weights, so fundamental representation, etc., which come from string junctions that extend away from the stack, so these blue ones. And so in the following, I will drop this kind of fiber geometry picture and just keep the what from F theory looks like the configuration in the base. And it is sometimes forgotten, but actually for our story quite relevant, that it's not only strings that form junctions, but also 5 branes. And again, from the F theory or M theory perspective, it's very natural to think of also not only M2 branes, but M5 branes wrapping such fibril cycles. And if you uplift the 7D M theory to AD, then you will find that these correspond to PQ5 branes of type 2B that are now within the internal space of type 2B, the P1 or the non-compact complex plane, just a line. And therefore, they are only also represented by junctions. And the fact that in at least without frozen singularities, in geometry, the 2 cycles are just 2 cycles. There's not really a distinction between string junctions and 5 brane junctions. This is reflected in the fact that, of course, in ADN equals 1, we can only realize ADE gauge algebras where the weights and co-weights or the roots and co-roots agree. And in terms of the more recent language of higher form symmetries, you can think of really these non-compact and compact 2 cycles being equivalent to just the quotient of co-weights modulo co-roots or root weights modulo roots. And this is nothing else than a group theoretic characterization of the center of the simply connected group associated with the algebra. Okay. So this is sort of the local picture, which we'll dive in a little bit deeper. Namely, locally, you can think of, or it has been shown in these old papers of the where string junction was first written down, that any junction, any physical junction that is not a root or co-root, it must carry some non-zero asymptotic PQ charge. And this is, of course, physically nothing else in the statement that if I just have a ADN equals 1 gauge theory, there are no matter. There's only adjoint, only a vector multiplet with adjoint states. So any state that is not in the adjoint representation or not roots must come attached with some external prong in the junction picture. And these external prongs are entirely characterized by their PQ charge. And the weight that such a prong represents generally is a fractional linear combination of the roots. And the fractionality of these coefficients are in one-to-one correspondence to the charge of the state under the center. And in this decomposition, what happens is that this fractionality is equivalently captured by the PQ charges that extend to infinity, which are called, and then this part is usually called the extended weights. And these type of extended weights actually have a representation as what's known as a fractional loop junction. in that if I take some junction with PQ charge RS and I move it around a 7-brane stack with certain monodromy M, then I end up with a net PQ charge that extends to infinity, just being the difference between the incoming and outgoing part of the song. And if I perform a Hanani-Witten type move, I can pull this part of the loop across these 7 branes. What I find is that for general values of PQ that extend here, these parts, these prongs on the individual 7 branes are fractional. Okay, and the point of this decomposition of a general physical junction is that the fractionality of the coming from the weight, which are some fractional linear combinations of strings stretching between these constituent branes, can be canceled off by adding appropriate multiples of these extended weights, which are also by themselves fractional, but in some they give you an integer or physical junction. So just to give an example, if I take SUN, then which is just n copies of mutual local 7 branes, which I call here A branes, then there's only one type of extended weight which are multiples of this one type with PQ charge 1, 0. And this can be equivalently represented as a loop that goes around the stack that starts off with only 1/nq charge. And this might look weird that it's fractional, but the whole point is that because it's fractional, it's not by itself physical, but needs to be attached to some weight to become a physical state. And what exactly this multiple is, this multiple A here, it tells you exactly what the charge of this weight is under the center of the SUN gauge loop. And this also works for more complicated, like SO2N, which has 2 types of loops or loop junctions to extended weight junctions. And depending on whether N is even or N is odd, you have a Z2 times Z2 or Z4 center. And again, you can work out that what the multiples of the PQ charges are determines uniquely what the corresponding center charge of the weight is that this junction represents. Okay, this is sort of the local picture. Now, globally, if I want to patch it together to a compact model, what happens is that there are essentially 2 non-trivial conditions. First of all, on the set of 7 branes, you have to require that the total monodromy of all the 7 branes is trivial. And also, in this compact setting, you cannot have any junction that has a prong going to infinity, because your compactification space has no infinity. It's a P1. So now this imposes non-trivial conditions on what exactly you can do to obtain string junctions stretching between 2 different stacks, which realize some massive matter representations, right? So depending on what kind of PQ charges can go out from one stack and what PQ charges can go into another stack, only certain types of PQ charges, certain type of string junctions can be formed in this global setting. And this is, and this of course means that there are certain states, there's a certain subgroup of the center under which all the possible states transform trivially. And there's an equivalent way of phrasing this in terms of 5 branes, namely 5 branes, if you think of them as the magnetic dual objects, they impose the trivial action of this quotient just via the Dirac quantization condition, right? They impose that only certain types of electric states that pair integrally with the magnetic states can exist. So there's been some very old work that shows how you can compute this quotient from what's known as a fractional null junction. And I will go through this not in much detail because time is running short, but basically the idea is that 2 such loops that can combine, I can also think of them as a loop going around all of them. And if I have trivial monodromy around everything, then this global null junction is just a trivial object. So yeah, I don't want to go into details of this. I just want to highlight that if you take a complicated example like that, and you have a null junction that starts off with a charge 1, 0, then you can do a similar type of Hanani-Witt move and show that it has this kind of decomposition in terms of the extended weights on each stack, and likewise the 0, 1 loop. And if you piece these things together, what you see is that all these coefficients are even, like in this case. So from this, you can deduce right away that the global gauge group topology has to be a quotient modded out by 2 Z2 factors corresponding to each of these null junctions. And you can also work a bit harder and figure out the gauge group topology, including the graviphotons. And in this case, there is a Z4 quotient for each of the U1 factors. Okay. Sorry for going too fast, but the details are a bit murky, so are a bit cumbersome to explain. So if you have more questions, I'd be happy to answer them later. Okay, so let me briefly now generalize this to 07 plus. So unlike the 07 minus brane, which splits into a B and C type brane, 07 plus doesn't really have a nice PQ7 brane description at finite string coupling. So for all intents and purposes, this is treated just as a single brane, which has the same monodromy as an SO16 stack, but has some non-trivial flux associated to it that freezes a singularity in its M and F theory description. And this freezing mechanism is 20 years old, but it's still sort of not very well understood. And what we propose is that from the junction perspective, you might get some better handle on at least this type of center symmetries, etc., from the junction perspective. But what is known is that in some sense this freezing is a local operation, even though in some of these works it's sort of described as a global property of some compact model. And it's local in the sense that in this work by Jutta and Kumran from last year, which demonstrates this very nicely, is that if you start with F theory on a K3, and you just as a purely putting by hand rule, replace 1 or 2 SO16 stacks with an 07 plus, this produces automatically all the rank 2, 10 and 2, 2 theories in 8 dimensions. Okay. And in this type of theories, you would expect that there is a different condition for strings and 5 branes to end on a 7 plus. So this is now different than in just ordinary F theory, where you don't really distinguish between strings and 5 brane junctions. And the expectation is from various type of perturbative analysis is that the prongs that end on an 07 plus must have even P and Q charge if the junction represents a string, and it can have any integer P and Q charge if the junction represents a 5 brane. And this is a really, I have to say, it's sort of a perturbative picture. I don't know how to derive this from a non-perturbative method at finite string coupling, but if I assume that configurations with 107 plus is dual to a CHL vacuum for which there are other descriptions, then this evenness condition or this different conditions on strings and 5 branes can actually be derived. Okay, so another cross-check for this condition is really coming from the fact that now with 07 plus, I can realize non-simply laced SPN gauge factors. And I should also be able to account for the higher form symmetries or their center symmetries. So this part here is just the same, a different way of phrasing how exactly I encode the fact that strings can come with only even PQ charge, but 5 branes can come with any integer PQ charge. So there are some sort of extended weights on the 07 plus, which are really just a single prong with a certain P and Q charge emanating from the 07 plus.
Ling?
And yes,
5 minutes.
Yes, thanks. And the SPN algebra is realized if I place just a bunch of D7 branes on top of the 07 plus. And also for this has the same monodromy as an SO stack. And for that, I can also introduce certain extended weights. And already at the level of roots, I see that the evenness condition on the O7 plus is necessary to give me the long root of the SP, basically because string junctions, which form the roots, have to have an even number of prongs or even p charge on the O7 plus. So in addition to all the short roots going between the A branes or the D7s, I necessarily have to have one that has two prongs going from one of the A branes on the O7 plus, and that realizes for me the long root. And likewise, if I talk about the dual co-roots, which are formed by 5 branes, then it's also consistent that the short co-root is just half times, in terms of a junction, just half times the long co-root. And that is also, again, an integer p charge that ends on the O7 plus. And then you can also show that, I don't want to go into the detail of this because I'm running short on time, that basically this modified rule accounts for the fact that even though the monodrome is the same as SO16, you really only have a Z2 center from taking the quotient of co-weights and co-roots in this modified setup. Okay, so yeah, as you would expect, if I now introduce these O7 plus with these rules, I can just determine the gauge group straight away with the same type of null junctions going around everything. And we find in perfect agreement with other results based on the CHL description. And in this case, also the momentum lattice is reproduced by the string junctions and the dual lattice by the 5-brane junctions. And for two O7 pluses, which realizes the series of rank 2,2, the junctions generate what looks also like a momentum lattice, though I don't really know if one has a description of these type of AD vacua in terms of some heterotic string compactifications. But again, we can compute certain gauge group enhancements along this branch of the moduli space very easily from the string junctions. Okay, so in the last few minutes, let me just describe the 90 uplifts of such theory. And this is based on a recent paper by Songju, Wolfgang, and Timo, who identified that in certain suitable infinite distance limits of F theory compactified on K3, you obtain an emergent description of a 90 n equals 1 theory. And these theories have rank 1,17, so 1 gravity photon, maximal non-abelian rank 17, compactified on a circle. And the way they are characterized geometrically is by singularities that are associated with affine algebras. And in terms of 7 branes, you can think of these affine algebras as just colliding certain E-type stacks with this very specific additional 7 brane. And from this collision, what you get is just that now you have certain junctions that represent the momentum unwinding states. So these are orthogonal to all the other gauge symmetries and just represent the modes you have from having an S1 compactification. And what these gentlemen have classified is that within these type of limits, there are 2 series essentially of geometries that describe the maximal non-abelian enhancements of 90 heterotic vacua. And these either have 2 factors of E and an SU gauge factor or E and an SO. Okay, and we can apply the junction rules to determine the gauge group easily in these settings to find agreement with heterotic results. So let me just highlight the situation with O7 plus. The idea is now just that we start from these configurations and do a freezing, which is that we identify a suitable SO16 subalgebra inside these things, including the affine, and by hand declare this to be an O7 plus brane, and then compute the junction lattice using the modified conditions for strings and 5 branes. Now there are at this point an ambiguity, namely the SO16 can fit in both in a larger SO or the affine E8. And if I freeze the latter, I get this type of brane, and if I freeze the former, as we said earlier already, you get the SP type gauge algebra. And at this point, we have to invoke again duality CHL to derive that, or to see that O7 plus must be fitted into an E8 in order to describe a 90 theory. So it's not clear to me how to derive this, but at least in terms of the duality, it's consistent and it can be interpreted as a freezing in 9D. And from this, you find the maximum enhancement to be either SU plus E or some SO18, and all of these are simply connected in terms of the gauge group. So let me just spend 1 minute on this slide because this is kind of important. So one possible further step of freezing is if you have two E8 hats, in which case you would put two O7 pluses into each of the E8 hats and get an SU2 gauge algebra in 80. This is expected to live on a rank 1,1 branch of 9D vacua that is dual to M theory in a Klein bottle. And it's sort of very suggestive that each time you do a freezing, what you do it geometrically in M theory is to insert a cross cap. So heterotic on a cylinder is just or F theory, or sorry, rank 1,17. You do once, you get CHL in 9D. Now you do it twice, you get this vacuum. But we also know that in 9D rank 1,1, there's a separate branch of the moduli space, and that's only connected to an AD deformation. And at the level of 7 branes, including the O7 plus, it's actually very straightforward to see that this configuration, this theory here is realized via this brane configuration. And in order to create a different configuration with a affine geometry, what you have to do is to separate the O7 plus from the C brane, which means that you go down from 90 to 80. And it turns out that after some suitable brane gymnastics, this is just a theory of two O7s and two O7 minuses, O7 plus and O7 minus, which have split into a B and a C brane. So this is known to be the dual description of the Daboga-Park background. And it's also known that this cannot be obtained from freezing. Okay, so from this, what we've seen is that basically all 90 n equals 1 vacua are somehow emergent AD theories. Okay, so let me just briefly put out the flash a summary and conclusion and some further outlooks. And thank you for your patience. Sorry for going over time.
All right, thank you very much, Ling, for a very nice talk. We have time for maybe one question. Yes, Matteo.
Can I ask? Yeah, so I missed, or maybe I didn't understand fully when you mentioned that you can track the higher form symmetries in these configurations.
Mm-hmm.
Can you like say repeat or revise that? How do you
Yes.
see it in terms of the PQ like brane or junctions that go?
Yes. So basically the idea was that any junction that carries some weight, some non-adjoint weight of the gauge algebra, that part, its charge under the center is entirely encoded in this external part, in this extended weight. So if I look at this picture here, all right, all I need to know is what is the PQ charge of this guy, and I will know what is the corresponding center charge of the weight that it represents.
Essentially, you keep track of the possible PQ charges that go off to infinity, and that tells you
yes,
spectrum, and so it tells you what type of higher form symmetries you can have.
Exactly. And if you're familiar with this kind of geometric analysis of these authors, then what the boundary of these cycles are nothing else but some torsional cycles on the like this kind of boundary geometry, which is like a twisted torus vibration. And the whole point is that with some certain modifications, you can do the same thing with O7 pluses. But in this case, since the geometry is the same, there must be some non-trivial thing attached to this flux that does the freezing, and it's not entirely clear from the geometry side how to explain this, but from the junction side, it's quite natural how you would, how you would explain this.
Right. Okay. And then so this freezing is not exactly the same, or maybe not equivalent all the time to like the say frozen singularities that we had just in terms of the pure field theory description, right? The geometry is, or the topology of the stuff is the same, but for us we had like coalescing of the 7 branes essentially that we wouldn't resolve and call that a frozen singularity.
Exactly.
Right? Is it
Exactly.
like a similar thing?
Yes, exactly. So as you just correctly said, I think in the freezing, all you say is you just don't resolve and stick with that singularity. But if you would study the boundary, then you wouldn't know a priori how to associate now your torsional cycles with with line operators.
It doesn't have like charges by itself.
Right,
Yeah.
right.
Right.
And the point of the junction is that it seems certain types of boundary cycles are just excluded once you put on this flux. And it would be nice now to to sort of derive this from the geometry or from the M theory plus flux perspective.